Good morning, students. Today we are going to start a new topic, conditional statements and converse. The statement which can be written in the if-then form are called conditional statements. Repeating, the statements which can be written in the if-then form are called conditional statements. The part of the statement following if is called the antecedent, and the part following then is called the consequent. Repeating, the part of the statement following if is called the antecedent and the part following then is called the consequent. We can discuss one example. Diagonals of a rhombus are perpendicular bisectors of each other. The statement can be written in the conditional form as if the given quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. The first one is general statement and second one is conditional statement. One more time, the diagonals of a rhombus are perpendicular bisectors of each other. The statements in conditional statement as if the given quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. If the antecedent and consequent in a given conditional statement are interchanged, the resulting statement is called the converse of the given statement. Repeating, the antecedent statement after if and the consequent, the statement after then, in a given conditional statement are interchanged, the resulting statement is called the converse of the given statement. You all remember, if a conditional statement is true, its converse is not necessarily true. Repeating, if a conditional statement is true, its converse is not necessarily true. We can discuss some of the examples. If a quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. This is conditional statement. Its converse, if the diagonals of a quadrilateral are perpendicular bisectors of each other, then it is a rhombus. In this example, the statement and its converse are true. But consider the next example. Conditional statement, if number is a prime number, then it is odd or even. The converse of same statement, if number is odd or even, then it is a prime number. In this example, the statement is true, but its converse is false because all odd and even numbers are not prime numbers. For example, 2 is a prime number, but 4 is not a prime number. 2 is an even number, also 4 even number. 3, 5, 7 are odd numbers as well as prime numbers. But 9 is odd number but not a prime number. So always remember this. It is not necessary converse of all the statements are true. If the antecedent and consequent in a given conditional statement are interchanged, the resulting statement is called converse of the given statement. Also, you remember, if a conditional statement is true, its converse is not necessarily true. We discussed two examples. First one, if a quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. Its converse is if the diagonals of a quadrilateral are perpendicular bisectors of each other, then it is a rhombus. This statement and its converse are true. But if a number is prime number, then it's odd. It is odd or even. Its converse is if number is odd or even, then it is a prime number. In this example, the statement is true, but its converse is false. We have studied many properties of angles, triangles, and quadrilateral through activities. In 9th standard, we are going to look at the subject of geometry with a different point of view, which was originated by the Greek mathematician Euclid, who lived in the 3rd century before Christian era. He gathered the knowledge of geometry prevailing at this time and streamlined it. He took for granted some self-evident geometrical statements which were accepted by all and called them postulates. Now we are going to discuss postulates. The symbol properties which we accept as true are called postulates. Euclid showed that on the basis of the postulates, some more properties can be proved logically. Many postulates we discussed in our previous videos. Euclid's some of the postulates are: there are infinite lines passing through a point. There is one and only one line passing through 2 points. A circle of given radius can be drawn taking any point as its center. All right angles are congruent with each other. Repeating, there are infinite lines passing through a point. There is one and only one line passing through 2 points. A circle of given radius can be drawn taking any point as its center. All right angles are congruent with each other. Euclid showed that on the basis of the postulates, some more properties can be proved logically. A property is supposed to be true if it can be proved logically. It is then called a theorem. Repeating, a property is supposed to be true if it can be proved logically. It is then called a theorem. There are so many examples of theorems. Vertically opposite angles are congruent. Opposite sides of a parallelogram are congruent. In a right angle triangle, square of the hypotenuse is equal to sum of the squares of remaining sides. These all are theorems. These all properties proved logically. So these all properties we can call as theorems. Properties proved logically are called theorems. When we are going to prove that a conditional statement is true, its antecedent is called given part and the consequent is called the part to be proved. For example, if a quadrilateral is a rhombus, its diagonals are perpendicular bisectors of each other. Here, given part is quadrilateral is a rhombus, and the part to be proved is its diagonals are perpendicular bisectors of each other. Logically, arguments made to prove a theorem is called its proof. For proving a theorem, there are three important steps. First part is given, second part is to prove, and third part is proof. You know the property vertically opposite angles are congruent. What is the given part of this theorem? Two lines intersect each other. What is to prove? Vertically opposite angles are congruent. One more time, I am repeating the statement of the theorem. If two lines intersect each other, its vertically opposite angles are congruent. Is the statement of the theorem. Its given part is two lines intersect each other at a single point. Its to prove is the vertically opposite angles are formed, or the vertically opposite angles formed are congruent. Proof we will discuss in next period. There are two types of proofs. One is direct proof, second is indirect proof. About direct and indirect proof also we will study in next video. So today we discussed mainly conditional statements and its converse. The statements which can be written in the if-then form are called conditional statements. There are two parts, antecedent also called as given, and second part is consequent. Consequent is also called to be proved. The statement, if the antecedent and the consequent in a given conditional statement are interchanged, the resulting statement is called converse of the given statement. Then we discussed Euclid's postulates. Infinite number of lines can be drawn through a single point. There is one and only one line passing through 2 points. A circle of a given radius can be drawn taking any point as its center. All right angles are congruent with each other. Next, we discussed about theorems. A property is supposed to be true if it can be proved logically. It is then called a theorem. There are many examples of theorems. Opposite angles of a cyclic quadrilateral are supplementary, or vertically opposite angles are congruent. Opposite sides of a parallelogram are congruent. Sum of the angles of a triangle is 180 degree, etc. Many theorems can be proved. The logical arguments made to prove a theorem is called its proof. For proving a theorem, you must write three important steps given to prove proof. Thank you. Have a nice day.